AP problem number 12. Part A. In the boxes provided, pretend there are boxes there. Draw the complete Lewis structure electron dot diagram for each of the three species below. So first thing I did was count the valence electrons. So 7 times 4 is 28, plus 4 is 32 valence electrons. So I knew that they would just be single bonds, because then this would be 2, 4, 6, 8, 16, 24, 32 valence electrons. PF5. So again, I counted the valence electrons, which was 40, so I knew that it would just be 5 Fs attached to the P with single bonds. So 8, 16, 24, 32, 40 valence electrons. And then for SF4, I knew there was going to be 34 valence electrons, so it would be 4 single bonds, 8, 16, 24, 32, and you'd need to add 2 more electrons, so I just added the lone pair right there. Part B. On the basis of Lewis structures drawn above, answer the following questions about the particular molecule indicated. What is the FCF bond angle in CF4? So, even though it's tetrahedral, we've read in a lot of the books that just because it's a tetrahedral doesn't necessarily mean it's a 90-degree angle. So, for this one, it's going to be 109.5 because the electrons are repelling each other. Okay, for part B, double I, what is the hybridization of the valence orbitals of P in PF5? And it would be dsp3. Part triple I, what is the geometry shape formed by the atoms in SF4? So here, you know that there's going to be 1, 2, 3, 4 pairs of bonded electrons and 1 lone pair. So looking at our little VSEPR chart here, we're going to see that here it's number of bonded electron pairs, 4, 1 pair of lone pairs, so that indicates a seesaw, which is what I wrote down right there. Okay. Part C. The two Lewis structures can be drawn for the OPF3 molecule as shown below. How many sigma bonds and how many pi bonds are there in structure 1? So if you look closely here, you're going to see that there's one sigma bond is a single bond, sorry. So it's going to be 1, 2, 3, and then you count this as just one unit. So it's 1, 2, 3, 4. 4 sigma bonds, and pi bonds would be double or more multiple bonds, so double or triple bonds, and there's only one of those. So I'm left with 1 pi bond and 4 sigma bonds. Part double I. Which one of the two structures best represents a molecule of OPF3? Justify your answer in terms of formal charge. So essentially you want to choose the structure out of these two that has the formal charge, which is closer to 0. So when I did the calculations for P, I got that the formal charge was 0. This is structure 1. And then the formal charge of O was 0, and then the formal charge of F was 0, because 7 minus 1 minus 6 is 0, and then for O, it's 6 minus 2 minus 4 is equal to 0. So overall, I could just stop right here, because you know that the formal charge for structure 1 right here is 0, so therefore it would be the best representation of OPF3.